Okay, the sum of three numbers is 855. So usually we call the three numbers x, y, and z. So we'll add them up, set them equal to 855. One of the numbers, x, is, so x is means equals 50% more than. So these numbers, we take all those words together, and what they are going to mean is a 1.5 multiplier. So 50% more than means we start with 100%, add 50%, that makes 150%. Then we remember percent means divide by 100 or move the decimal twice to the left. So that gives us 1.5. So 1.5 times the sum of the other two numbers, which would be y plus z. Okay. What is the value of x? So we want to know x. Now normally under these circumstances we would want to have three equations to solve for three unknowns. But in certain cases we can still get part of the work done with just two equations. So let's see how that works. Well, first step is we're going to want to distribute here the 1.5. So we end up with that. Okay. Next, we're going to want to, to solve for x, we're going to have to get rid of y and z, right? So to get rid of y and z, let's see what we could do. Well, one thing we could do is we can have all the x, y, z on one side. So I'm going to swing this over to this side by subtracting 1.5y from both sides. And so I get x minus 1.5y. And then I also do the same thing with the z. Subtract from both sides, minus 1.5z. And on the right side I'll get 0, right? And now I compare that with my other equation, which is x plus y plus z is equal to 855, was it? Yeah. Right, so now I add up my columns and I will get 2x, right? Whoops, actually before I do this, let me see here. I'm also going to need to multiply through. Yeah, so I'm going to multiply through by 1.5 on this entire bottom equation so that when I combine these, the y and z will cancel out. I don't want the x to cancel out, right? So I end up with 1.5x plus 1.5y plus 1.5z is equal to, and I need to do the math for this, 855 times 1.5 would equal 1282.5. Okay, and now I'm going to rewrite the other equation underneath here. Okay, equals 0. And at this point, now is when I can subtract, or in fact add these two lines. So when I add these two lines, I get 2.5x, the y's will cancel and the z's will cancel because we have opposite signs, equals 1282.5. So now I simply have to divide by 2.5 on both sides. Alright, so I'll divide my answer by 2.5. That gets me 513 for x. So x equals 513. And let's see if that's a choice, and yes, it's choice B. Alright. 23. The angles shown above are acute, and sine of A is equal to cosine of B. Okay, so this is a key idea from which I could conclude that A plus B would have to equal 90 degrees. Because this fact is only true if the angles are complementary, right? And it comes out of the idea of cofunctions, right? So if you could study up on your cofunctions, then this will be clear to you. But the idea is that the sine of 90 minus x would equal the cosine of x, because these are cofunctions. Okay, so we know that a plus b is equal to 90. If a is equal to this and b is equal to that, what is the value of k? So we know that a plus b is 90, so we could just take the expressions for a and the expression for b, add them together and set them equal to 90. So now we have 10k, and then we combine these guys to get minus 35. Okay, and then we add 35 to both sides. We get 125, and this is 10k. Divide by 10 on both sides, and we get k equals 12.5. Answer choice C. Mr. Cole has a beaker containing n milliliter milliliters of solution to distribute to the class of chemistry students. If he gives each student 3 milliliters, he will have 5 milliliters left over. Okay, so this is going to be a division slash remainders problem. Okay, so remainders. Let's see. In order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. How many students are in the class? Okay. So, we take n milliliters, all right, and we give each student 3 milliliters. So if we divide that by 3 milliliters, right, then we'll get the number of students here. And it turns out he has 5 milliliters left over. So then instead of so you know what I could do is I could do, okay, there's 3 milliliters per student, right, per student. I could times that by the number of students. So let's call it X students. Okay, and then so I'll have 3X would be the number of milliliters that I handed out to those students. And then I still have 5 milliliters left over. And that is going to equal the total number of milliliters, which is n. Okay, so if I get rid of the units, then I have 3x plus 5 is equal to n, right? And of course I'm looking for x because I want to know how many students there are. So it looks like, basically I'm sort of thinking of a number that when you divide by 3, you end up with a remainder of 5. So if you divide by 3, you get a remainder of 5. In order to give each student 4 milliliters, he would need an additional 21 milliliters. Okay, so we can make another equation out of that, right? So we can forget about that for a moment. So to do 4 milliliters per student, and again, the units really help out here, for X students, okay, that would equal n milliliters, but we would need to add 21 milliliters. So we would have to have n plus 21 milliliters for that to work. Okay, so let's just get rid of the units for a moment, make it a little bit simpler. So we're just looking at 4x is equal to n plus 21. And here we have 3x plus 5 equals n. So here we have a system of 2 equations with 2 unknowns. So of course we know how to solve those. And in this case we're looking for x. So we want x, we have to get rid of n. So to get rid of n, we can isolate for it and plug in. So here it's already isolated, so we can plug it in for the n that's here. So we get 4x equals 3x plus 5 plus 21. So we get 3x plus 26. We subtract 3x, both sides. We get x equals 26. And that's answer choice D.